This short video tutorial is to demonstrate, describe how to project a raster. I have a raster in my table of contents named Hillshade, and I would like to project it so that it lines up with my other projected data. If I zoom to layer, it shows that my raster is way out in space and nowhere near my rest of my map. I want to project it. I go to Arc Toolbox, Data Management Tools, Projections and Transformation, Raster, Project Raster. Double click. The input raster, of course, is Hillshade. In this case, the input coordinate system is listed, GCS, North American. That means Geographic Coordinate System. I'm going to navigate to my data lab 7. Notice how it popped up to the right spot. I'm just going to verify that with my down arrow, G directory data lab 7. I'm going to click on Hillshade, and I'm going to shorten this up to Hillshade PROJ and hope that that is short enough. Say save the output coordinate system. Select projected state plane NAD 1983 Harn US feet, and then navigate to Washington South, add OK. I do need a projection transformation because the green light is on. I'm going to scroll down to WA-OR. In this case, I'm going to click on Tool Help because I want to see some information. Let's say, for example, that I'm not too sure on how I want to project. I notice a couple things. One, the coordinate system defines how the raster data is projected. That's an important piece of information. The coordinate system defines how the raster data is projected. Spend a moment and read this information from summary down to snap raster setting will take priority over the registration point. We don't need to get into syntax, but this information up here is important information. Specifically, we have to know which option we should use for this continuous data. The Hillshade is continuous data because there is no point that has zero Hillshade. There is always something, which means we need to look in here for continuous data. Start at the top and read through. We notice right here that it says it is not recommended that nearest be used for continuous data, such as elevation surfaces, which is what we have. We have a hillshade. And then we notice that the bilinear option determines a new value of a cell, and then the cubic option, cubic convolution, determines the new cell value by fitting a smooth curve throughout the surrounding points. These are most appropriate for continuous data and may cause some smoothing. That is what we're looking for. We're looking for cubic. I can close this Arc10 Help, and instead of nearest, I change this to cubic. We're going to leave the output cell size and not choose a registration point. Once we're done and we've verified the information, click OK. And very quickly, in 4 seconds, the raster is projected. I click Close. Notice how it is added to the map. However, I just encountered a serious application error and am unable to continue. This is why you save early and often. It even happens on the fastest of machines. I'm going to pause, shut down, and bring up my document again. Before I shut down, I'm actually going to do this. I put in my real email address and just say projecting a raster, cubic, via cubic, and that'll be enough. I say send error report. Hopefully it goes. And now I'll pause it while I pull ArcMap back up. I'm back from catastrophe. I've added back my layers, my hill shape project. I'm going to zoom to the layer, and it's zooming right to the right spot. If these were all turned off, I would be able to see my raster. There's my raster. Notice how the water goes in the lowlands. So it worked. That is a great example of why you should save early and often. I'm going to actually save right now. File, save as. I'm going to call this map 2. And that's how you project a raster.